Well, welcome to today's Strategic Farming Let's Talk Crops program. We're happy to have you join with us for today's session. Today's session is on efficacy matters, fungicides for specific corn diseases. These sessions are brought to you by the University of Minnesota Extension and generous support from the Minnesota Soybean Research and Promotion Council, the Minnesota Corn Research and Promotion Council. I'm Dave Nicolai. We welcome you to today's session. I'm an extension educator in field crops. We welcome our primary speaker, Dr. Kirsten Wise. Kirsten is a professor in the Department of Plant Pathology at the University of Kentucky with primary responsibility for extension and research on diseases in corn, sorghum, and forages. Kirsten earned her BS degree in Plant Health and Protection from Iowa State University, her MS in Plant Pathology from the University of Georgia, and completed her PhD work at North Dakota State University, also in plant pathology. Prior to joining the faculty at the University of Kentucky in 2017, she was at Purdue University for 8 years as an extension specialist for field crop diseases. Her extension and research program focus on developing economic and sustainable disease management practices for agronomic field crops. And with that, I'm going to turn it over to Kirsten at this point in time and talk a little bit more about the Crop Protection Network and fungicide efficacy. So take it away.
All right. Thank you, David. I appreciate the introduction and the opportunity to talk to you all today. So in my introduction, I am at the University of Kentucky. I'm a plant pathologist here, primarily working on corn, sorghum, and forages. But I also wear another hat, and that's as a co-director for the Crop Protection Network. And that's what we're going to talk about today is how that extension group, it's a multi-state extension group. We have a lot of resources, particularly on fungicide efficacy and economics of fungicide use, that I think would be really helpful for people as they're trying to make some decisions around whether or not to use fungicides. And so I'm going to try to advance here. There we go. So if hopefully some of you have seen the Crop Protection Network, here's a picture of our website, and the website is going to be in the chat and then also on the slides. And this is just, like I said, an extension resource. If you see that logo, you know it's extension, and it's based on issues that don't stop at state borders. So these are going to be multi-state pest management information, articles, resources that you can get at this place. All of it is free. And so, just like extension, it's going to be free, providing the unbiased research based information. And in case some of you are not as familiar with the Crop Protection Network, I always like to tell sort of our origin story. If any of you are into Marvel or any of the comic book type things, anything that is great has a good origin story, right? And our origin story, as some of the comic book type things, comes from a disaster of its own, and that was Hurricane Ivan. And so some of you who are attending today may remember in 2004, all the way back to 2004, what Hurricane Ivan is thought to have brought to the United States, which was soybean rust. So many of you probably remember, I call it the soybean rust craze, where there was a lot of information, a lot of concern, a lot of really worry and heartburn about what this disease might do to the soybean crop in the US, because it was very devastating in Brazil and South America where it had been established. And so there was a massive extension effort to develop and disseminate resources of what we knew about soybean rust, how it might infect the crop here in the US, and what people might need to do. And what it ended up with was, you can see here on your right, a lot of the extension fact sheets that came out during this time. But what we were finding out as we were all putting out our different fact sheets is that, there's only so much information. It hadn't been established in the US. We didn't really know how it was going to cause yield loss or what kind of concern it might be. And so all of these fact sheets said the exact same thing. And so we were all putting out the same information. And we thought, hey, really, is there a way that we might coordinate and reduce the duplication? If we're all saying the same thing, maybe it's better if we say it together. And we were able to get some resources. You can see there The Using Foliar Fungicides book was very popular for a long time. We had some mapping efforts that were very popular and have evolved into other types of maps now. And there were a lot of people that contributed to this. This was really a national effort of all of the extension plant pathologists. But when it came time to put logos, for all the universities or where to house the information, then it was just a challenge that we really hadn't thought of. And I will never forget one of our ag communication specialists told us that it's called the NASCAR effect. When you try to put all the university logos onto one publication, you just lose the efficacy of the branding. And I also remember when I started at Purdue, Soybean Rust had been around for a couple years, but no one in Indiana wanted to go to an Ohio State website to get this information, and that's where it was housed. They all wanted to be able to either get it at a neutral site or they wanted it to be a Purdue site. They didn't want to go to Ohio State for a resource. And so that was also a challenge on where to locate and point people towards these resources. So I think we learned a lot from that soybean rust sort of outbreak. And then what we did in 2015 is we just built our own national network and we called it the Crop Protection Network. And if you've seen the logo on the screen, that was our original logo when we started, because when we started, we only had outputs for corn, soybean, and wheat. And we've evolved now. We now also have alfalfa and cotton in our repertoire of extension information. And so we've evolved our logo is now what you see at the bottom of the screen. So again, if you see that logo, it's a trusted resource. It is a product of land grant universities. It is extension, again, across state borders. And if you haven't heard of CPN, you probably have seen the content because our outputs are always reposted or repackaged a lot by industry. The Hefty Brothers are another group that's not on here that use our content quite frequently. So sometimes you might not see the brand, but a lot of our content and that multi-state information is getting reused by other groups. Now we have a range of outputs. I'll talk a little bit more about some of the specific ones that might interest you at the end. We started with just publications, but we now have web books, we have webinar series, podcasts, newsletters. We have, if you're ever wondering how much a certain disease or insect pest caused as far as yield loss, we have those tools available. So a lot of different resources that you can go and get information about. And this is just kind of a summary of that. Over 100 extension publications. I always like that a lot of our publications, a lot of our webinars, if you use those, you can take a short quiz at the end and get some CCA continuing education units. And so those are some things that would also provide some CCA credits for using some of the CPN outputs. But what I want to kind of focus in on today are the fungicide efficacy guides. These by far annually are our most accessed publications on the Crop Protection Network. And they are usually annually updated in every February or March. Ours were just released a couple of weeks ago, so they are fresh, they are new, available for you. And this is a national effort. So when you see this on the Crop Protection Network, you can know that most of the extension specialists in the US are contributing data and ratings to these publications. And sort of how that works is that all of us are conducting efficacy trials in our states each year. And then usually in December, I send a call out to all of our extension specialists for corn, soybean, and I say, hey, how did these products work? Are there any changes that need to be made? Are there any products we need to add? Do we feel we have enough data to provide a rating for some of these? And then we have some discussions about what changes should be made, what things we should try to do. And that's when we start to update and populate this table. And I will say that most of us are making these decisions based on replicated research data. And sometimes we don't have enough, or maybe we didn't have enough disease in a particular year or field to really make a good judgment. And so sometimes you might see something like a U, which means it's unknown for some products that are very heavily promoted or marketed. And that just means that we haven't seen either enough of that product, we don't have enough years of data, or we haven't had enough disease of a particular disease to really feel comfortable that we can back up that rating with replicated research data. So I would say that we are pretty careful in the ratings that we put out. But one of the things that I did recently, as a group, we kind of decided to look at that question of how well do these ratings translate to disease control? Because we get that question, right? So we're kind of summarizing our national sort of efficacy trials to do this, but everybody is reporting based on what they see in their state. But if we were to take data sets from these states and look at how these product ratings correspond to disease control, in this case, we were looking at gray leaf spot management. You can see gray leaf spot is our disease. It's very common. It has, those sort of long rectangular lesions that expand across the leaf veins and can be annually yield limiting in certain areas. And so took a subset of data from some of these states and then looked at how our fungicide efficacy rating for gray leaf spot corresponded to the reduction of gray leaf spot severity in both low disease pressure trials, meaning that there was less than 5% disease severity in those trials, or high disease severity trials. And those would be the blue bars, and that would be where we had more than 5% gray leaf spot severity. And so what you can see is that the good news is that all of the products we tested reduced gray leaf spot severity in low and high disease settings. But what you're finding is that if a product is rated very good all the way up to excellent, we're seeing, a pretty substantial reduction in gray leaf spot compared to products that are just rated as good for gray leaf spot. So and then also I think this is also pretty interesting is that if you don't have a lot of disease, we're not seeing big differences in efficacy, differences in reductions of disease, because there's just not a lot of disease out there to control. Now, we also looked at this for southern rust, which is, maybe not something you see so much in Minnesota, but it is really important in the Mid-South, the South. This is probably our most annually yield limiting disease in Kentucky. And so this was important for us to look at too, is that what type of reduction of southern rust should we expect to see from products that are rated in these different categories? And again, it sort of went back to, if you're seeing low disease pressure, if you don't have a lot of disease out there, it doesn't matter as much. But if you have high disease pressure, our very good to excellent fungicides, we're providing a little bit more disease control than something that was rated as fair to good. And the next question I always get asked is how these how these classes relate to yield response, right? Because it's not enough to just control the disease. What type of yield response should we see from that? And so this was what the yield response looked like for gray leaf spot, same data set, looking at how much did we gain or not gain from the fungicide application across these different efficacy classes. Again, for low disease pressure, under 5%, or high disease pressure. And so again, our low disease pressure, saw some sort of modest yield gains, whereas our very good to excellent products, we saw just a little bit of a yield gain compared to something that was just rated as good. And then the same with our southern rust is that, again, under low disease pressure, we're not seeing much of a yield response because, where we see the biggest yield responses are where we have disease pressure. And that came out here, again, our very good to excellent rated fungicides for southern rust. We're providing the best yield response that we were seeing in this particular data set. And so that was sort of gratifying to kind of just ground truth the fact that these fungicide efficacy ratings correspond to disease reductions in disease and also some yield responses as well. But another way to look at this in a more comprehensive way would be to look at our uniform fungicide trial results. And so this is an effort that's we've done informally since probably about 2008. And if Dean's on here, he can comment because he's participated in these in the past. And that's something we used to just kind of mash all our data together and kind of look at how fungicides worked against different diseases or different yield responses. And what we started doing, in 2014 was the year that we really started to be more precise about it, where everybody you see on the screen was conducting the exact same trial in their state. So that's why we call it a uniform fungicide trial, is that we're all doing the same thing. So we have really comparable, nice data sets that we can analyze in specific ways and learn more about how these fungicides are impacting both disease control and yield response. And so what I'm going to show you is some of our sort of hot off the press results from 2019 to 2022. So a good stretch of data looking at, in particular, how these fungicides that we were testing were influencing yield. Here are the different protocols that we were analyzing. So in 2019 to 2020, we were looking at tasseling applications and then followed up by a milk stage application at R3. So just a replicating, comparing if you were going to spray at tasseling, which is sort of our gold standard for when we want to apply fungicides in corn, and then compared to a later application. In 21 and 2022, we were looking at pre-tassel applications. Those are really popular, especially down in Kentucky. You can get across the field with your ground rig. You're not really waiting around for a plane to come apply. So if you can get that fungicide application on prior to tassel, you have a little bit more flexibility in your application system. So we tested some products at that timing and then compared them to that tasseling, again, gold standard timing. Also in 2021 and 2022, we had a trial where we were looking at the in-furrow or at plant fungicide application that for the product that is labeled for foliar disease control. That's Xyway. We use the LFR formulation. There are a couple formulations. We were looking at the liquid fertilizer release formulation in furrow as a 2x2, and then as in-furrow followed by a tasseling application, and then comparing it to some standard tasseling applications. And that was right sort of as that product was launched, and so trying to get some data around how that one worked. A little bit more information about the trials. So these trials were conducted across 19 different states. Again, they were uniform. Almost most of those treatments that you saw on the previous slide were included in these studies. So that actually resulted into 151 studies with over 1,000 data points that we essentially what that means. So if you look at the map, anywhere you see a big blue, the larger the size of the blue dot, the more more trials were conducted, the more data is included. So this is something that I collected all this data, but then I've worked very closely with Damon Smith at the University of Wisconsin, and he has a data science institute that, when we started doing this, we were doing some preliminary analyses and things, and they really took it to the next level. They're data scientists for a reason. They're very good at looking at data. And so they've really elevated what we can look at with this data set by having them involved. So I'm very grateful for their help and participation. Some other things to kind of think about with this data set is that if you think about the years of 2019 to 2022, we had a couple years, 2019 and 2021 in particularly, that were very high tar spot years. So you all in Minnesota are very familiar with tar spot, I'm sure, one of our newer diseases in the United States, and does have the potential to cause significant yield loss. And so those 2 years had a lot of tar spot data. And then those were also years in 2022 as well that the South had very high southern rust. And southern rust is a very important disease in our area, like we mentioned, and can cause very significant yield loss. So when we know that those two diseases are going to be in this data set, it's really important to point that out, because if I had to pick two diseases that have the widest range in how products control these diseases, it would be tar spot and southern rust. So if you go back to our fungicide efficacy table, there are products that are really good against these diseases, and then there are products that are commonly used that are not as good against tar spot management or southern rust management. And so keep that in mind when you're looking at the data, because when we're looking at the yield response and the economic outputs, that is influenced by how well these products controlled these two diseases. Now, we have some economic data in here. I want you to kind of take this with a grain of salt because it is based on our national median for these individual products and the application costs. And this is going to be really specific to your area. For instance, in Kentucky, our application costs are going to be a little bit different than your application costs in Minnesota. Our product costs are going to be different too. Some products are promoted more heavily in the north than the south, and vice versa. And so that pricing is going to be influenced as well. So just use these as a reference, just some food for thought, and sort of think about what your pricing, what your application costs, what your product costs would be for your own system, and kind of use that, just use this sort of to get your brain thinking about the economics of it. Now, we're going to talk first about the overall disease effect, or essentially, in other words, how well do these products control disease? And we're looking at that here where you're seeing, okay, this is going to be our, meaning that we have a lot of disease control over here where we have some that, we're not as good at controlling disease. But mostly these, we're going to see a lot of good disease control. As long as it's below zero, it's controlling disease. And then if you look at that disease effect size by treatment, broken out across the different products that were tested over these years, you can see here, that red bar is at zero. And we want all of these bars, we want these lines here to all be under zero. And that was the case. So all of our products were controlling diseases. But you can see there are some that are going to do a little bit better job than others. Again, that goes back to the fact that these were tar spot and southern rust heavy disease years, and some of these products are just not going to be as good at tar spot and southern rust control. Now, if we're looking at yield, this is also, something we want to see above zero. So we were seeing some pretty good yield responses, overall positive yield effect size for using fungicides. And I always like to point out that, like I mentioned, we've done these analyses for many years. And so, here's another graph from when we did this in 2017. And the graphs, if you go back and look at the 2019 to 2022 data and the 2017 data, it's very similar. We see similar responses to yield increases from fungicides among these data sets. It is pretty consistent. Now, if you looked at the yield effect by the fungicide tested, so this is by the individual products that we looked at, again, that zero bar, we want everything to be above zero, particularly that middle blue line. And in most cases, we were above zero, and some we were just barely above zero. But you can see there that some do a little bit better than others, and some, but most of them are just at least above zero. And a lot of that is going to be influenced by the disease level. This is no surprise to any of you here. But if we're looking at low disease severity, which is up here on top, compared to high disease severity, just like when we broke it out for our efficacy trials, this makes a big difference in what type of yield response you're going to see. And if we're looking at 5 bushel an acre, $5 corn, maybe a little optimistic, but that's what we're going for. We were looking at, in low disease situations, 31% of those trials were profitable. But if we had high disease pressure, a little over half of those trials were profitable. And this is similar to our past studies as well. But again, that disease level is going to influence how profitable and what type of yield response we would see. I always like to point this out just because, I get questions about what does 5% severity look like. People think it might be just like one or two lesions on the leaf, but it actually is a good bit of disease. Plants can handle some disease. So I think that's important to remember. Just kind of keep in mind that we have these assessments available on the Crop Protection Network. If you're ever curious about how much disease is out there, you can go and get some rating charts and take them out to your field to know for sure. So we want to look also at that yield for low and high disease severity broken out by the different products. So the low is going to be the blue, and then the high disease pressure is going to be in red. So again, if you have disease pressure, if you have a situation where we're increasing disease risk, you're far more likely to see a positive and a profitable yield response compared to when you have less disease pressure. Now, there are some situations that you can see there where it's a pretty, it's not a, you don't have to laugh at that yield response even under low disease pressure. But if we're going for consistency, using these products, we want to see consistent results, and we consistently see those yield responses when we have high disease pressure. Timing is another thing that we tried to look at with this, because if you remember our protocols, we had, tasseling, or that would be our R1 silking application timing, compared to post-tassel or pre-tassel or in-furrow applications. And you can see here, almost all of those are positive. We did not have a lot of data for the 2x2, so I want to make sure I point that out, that that's a little lower powered observation. But you can see there that, I think we had the most observations in our tasseling silking timing, and it just has a little bit of an advantage as far as the yield effect size compared to the other timings. Now, if we're going back to that percentage of profitable cases, if we're looking at the economics of it by product for $4 corn and $5 corn, again, if we're at $4 corn, a little less than a quarter of the time were we profitable under low disease pressure. And it was 30% of the time if we were able to get $5 corn under low disease pressure. But again, that changes under high disease pressure. And then it's more like, 43% and 52% for $4 corn and $5 corn. Now this is there's a lot going on here. So let me kind of break it down for you. So this is just going to be your return on investment for $4 corn for these individual treatments. That red line is our zero. That's our break even. And for $4 corn, that blue line that's kind of going through there, that needs to be above the red line for you to have a profitable response for these individual products. And at $4 corn, with our data set, there just were not a lot of products that we were getting a consistently profitable return on investment at $4 corn. Now, if you look at the $5 corn, it definitely gets better, right? So at $5 corn, this blue line is higher over a wider range of products, and saying that you're more likely to see a positive return on investment in dollars per acre at $5 corn compared to when you had the $4 corn. Now, something I want to point out, I get asked a lot of questions about Xyway, and in our data set, Xyway was not profitable in $4 corn or at $5 corn by itself. And the reason, again, is because our data set is primarily influenced by tar spot and southern rust. And Xyway just, it's a good fungicide against things like gray leaf spot and northern corn leaf blight. But in a lot of situations, it's not going to quite have the power. It's not going to be as efficacious against tar spot and southern rust. Now, I need to point out, Xyway followed by a tasseling application of TopGuard EQ is more likely to be profitable. That response and disease control is much better when you have that tasseling application. So it's kind of summarizing and thinking about these fungicide applications. I think we were able to see products that work well against some diseases. Some products don't work as well against certain diseases, and that really kind of showed out in this data set when you looked at individual profitability of individual products. The message really hasn't changed. Yield gains are possible with most products, but a yield gain does not equal a positive return on investment. It's really important to remember that you can get a yield gain, but it doesn't mean you're getting added profit. And so in our situations, if we look at $5 corn, about half of the applications were profitable under high disease pressure. But if you didn't have a lot of disease pressure, it was only about 30% of those applications. And so we're thinking about other management options to maximize profit because, if we're using things like we're selecting hybrids that have greater resistance to our foliar diseases, we have decades worth of data that show that fungicides, you're not going to see a profitable response when we're spraying fungicides on resistant varieties because the hybrid's doing the work, right? So that's really important. You can save money on your fungicide in that situation. If you're planting on time too, so we see more disease in our later planted corn and our later planted crops. And so if we're able to get in on time, I know we don't often have a lot of control over that, but that does also influence disease pressure. And residue management, I can't say much about this. Kentucky is a no-till state, so we aren't able to do a lot of residue management, but I know in Minnesota that might be possible because a lot of our organisms that cause foliar diseases are going to survive from year to year in the residue, and so residue management will help reduce the amount of a fungus or a pathogen that's there for the next crop. And this message, I always point this out. So we've done these, trials. We continue to analyze these data sets, and I think we get a lot of good information out of them. But our message really hasn't changed since the first time I did one of these presentations about like the mashed together data in 2009 of all of our multi-state trials, is that our trials, our trial results indicate that fungicides are most profitable in corn when you have factors that contribute to disease risk. If you have the disease and you have these factors that contribute to disease risk, then the fungicides are more likely to be profitable because you have disease in your corn. So planting susceptible hybrids, continuous corn, the late planting we talked about, irrigation can create an environment that's favorable for disease to develop. Of no-till or reduced till, some of these weather patterns that influence disease. And ultimately, if disease develops, that's where we see the strength of fungicides is in controlling disease, right? So that's where they're most likely to be effective and profitable. Now, I know a lot of you you don't just grow corn, you grow soybeans too. I am a corn pathologist now. But I wanted to just mention that our soybean group has started to do these uniform trials as well. Now, they have not been doing them since like 2008-9 as we have in corn. They've started them a little bit more recently. So there are some multi-state efforts that are out there, but now there is a large national effort underway. So some of the data that we've been doing for corn, these type of results, there should be some coming out for soybean very soon. And just to kind of point out some of the newer resources that we have on some diseases that I think are of interest to you all in Minnesota for tar spots. We have some new webinars. We have 3 webinars that were just released since January on the latest information on tar spot. So I'd encourage you to watch those. We have some updates on management available. And so those are going to be really good. Each one is about, 30 to 45 minutes. And you can get some CCACUs for watching those. We also have some new research reviews available for tar spot. We have maps of tar spot distribution in the US. Those have been added to CPN. And we have a lot of other good, just sort of general information on tar spot at CPN as well. White mold is a disease I know that's also of interest to you all. And so I wanted to point out that we have a lot of good articles on white mold. Some of those are going to be based on the latest research that I think has come out of, some of it has come out of Wisconsin, particularly some of their disease forecasting that they have for white mold. And then just to kind of point out, one of the things that we have are these what we call research reviews, where we take actual research and kind of summarize it into a more digestible type language with some good summaries and some good take home points for those. And so here's what the brand new one we have against for tar spot, and how things like fertility and plant population is going to affect tar spot. So I'd encourage you guys to check those out too. And just kind of keep in mind that, again, we are multi-state information. It's a good long-term university collaboration. We're lucky to have a lot of involvement. Dean has also been really involved with CPN and provides information too. And so just kind of bookmark this website. If you have questions about pest management topics, this will be a good resource for you as you start to enter the season. And with that, I would be happy to take any questions.
Well, thank you very much, Kristen. We had a couple of questions that did come in. One is in regards to the trials themselves. When we talk about the multi-year trials, a question the participant had is, were all products tested in the same year at the same locations?
Yes, for our uniform trials, most cooperators are testing all of those products. Now, there might be some that they can't get. So there might be one or two that isn't tested, but most cooperators, if they do the uniform trial, are going to be doing as many of those products as they can in the same location in the same trial.
Okay, great, great. Um, let's just one of the other questions that did come in was in regards to indications with the I think you already alluded to it, and that's classifying the diseases from the standpoint of whether they're high incidence or low incidence and so forth. So in that regard, I think that also would be a possibility to talk about.
Yeah, so when we're doing our analysis, we're always sort of grouping it as low disease, how it looks under low disease pressure, which is less than 5% disease severity. And then we look at how these products perform under higher disease pressure, which is over 5% disease severity. And so that way we are really get a good feel for how products, what type of response we're getting under minor disease pressure or no disease pressure versus how they work when they're really tested by a lot of disease.
Okay, very good. And then another point that came across, and that is plant health. And in terms of this, because we have some areas in northern Minnesota, and you did some time at North Dakota. When it regards to things in terms of when we're talking about maybe lack of disease, maybe tolerance and so forth in the hybrids and so forth, are we seeing responses? And I know that sometimes there are claims that way. Or is there something else going on here? How do we segment or parcel this out, from a disease pressure? If you can't physically see it, if it's not apparent, is there a lower level of here, or is there some other plant health? Now, this may take, 4 years on a thesis project someplace or longer, but I don't know if you want to touch on that a little bit.
Sure, I get asked this question all the time. So, so this is an easy one to answer. So when you hear the term plant health, it's a very all-encompassing term, right? But we can definitely say that we can see things like some of these fungicides when we apply them, particularly to corn, we can see that the corn stays greener longer, right? So you can see sort of a greening effect. We hear a lot of claims about improved standability using these fungicides. And we hear about yield benefits in the absence of disease. And I can tell you in our research, depending on the year, we can see one or all three of those things. However, the thing to think about isn't plant health effects, it is what is your economic response to the fungicide? So when we see plant health in the absence of disease, it is usually a modest yield increase, if any. So when we're using them in the absence of disease, and you saw some of the low disease pressure data that we have, we can get some yield gains, but they're not going to be the double-digit yield gains that we sometimes need to be profitable. So there's a difference between a yield increase and profitability. And that's really like if I had one take home message, it would be that we have to separate those two because yield increases do not equal profitability. So with plant health, we can see it. It is a real thing. We do see it sometimes, not consistently, not every year, every location, every hybrid. We can see it, but it doesn't always mean that you're getting a profitable yield response.
So it depends, is what you're really saying to some extent here.
No, I think plant health is there. I think that is something that you can see. You can see the corn stay greener longer, but it doesn't mean that you're getting a yield increase that's going to pay for the cost of the application.
Okay. One of the other questions that came in is there in the studies, did you take a look at or has this been probably segmented out maybe in smaller studies in terms of different application types? Now, in Minnesota, say, for example, if we talk about tar spot applications at VT and so forth, typically it's airplane. What about ground? And of course, the newest thing, of course, is drone. Has the data been coming in on that on the crop protection network, or where are some other places people can look to find out some more information about different application methods? And what's your recommendation too, by the way?
Yeah, so in our studies that I presented today, almost all of those are going to be applied by ground, or backpack, or something that's not aerial, so not a drone or not a helicopter slash plane. So that would be one set of data. But more and more of our university folks are looking at those methods. For instance, in my program, we have a drone. So we have been looking at drone fungicide applications compared to ground applications. And there's a couple of us in not only in the US, but also in Canada that have been comparing helicopter or plane to ground to drone in all in one trial, trying to determine if we're seeing sort of the same coverage and efficacy type responses. And I can tell you, so in the last couple of years that we've been doing the work, we haven't had a lot of disease pressure, so they've been very low disease pressure years. But in those low disease pressure years, all three of those application systems have provided good efficacy. When I recommend this to farmers, we have done a lot of ground versus aerial type application, and now we're adding in the drone as part of the aerial application. I would say that one of the things that I always tell farmers is that you have to trust your applicator. Like, is your applicator using the carrier volume that you need? Are they carefully spraying? Are they making sure that you're getting the overlap in the passes for both aerial and ground? With ground, are they not tearing through the field, knocking down extra corn? So it really is gonna, like, the response of the application is gonna depend on how well your applicator does when he's doing his job. And if you trust your applicator, I think you're going to be happy with the results.
In terms of some of the data that's collected in the multi-state trials and so forth, do any of those trials, in addition to looking at yield, evaluate standability at harvest in addition to yield and disease pressure?
So I'm sorry, can you ask, the question was about the standability and disease pressure? It broke up
Right,
just
right.
a little bit.
Yeah,
Okay.
yeah.
Yes.
In other words, they're taking harvest notes, at the time. Is that recorded or listed any place in terms of standability of the corn of the hybrid in the trial? From disease pressure, but in interaction with the fungicide application, in addition to yield.
Yeah, so in our uniform trials, standability is not always taken. It's taken in some subsets. So I have looked at subsets of data that have standability, and in my own, we take standability data in every trial that we do. And I can tell you that in ours, we can see some benefits if we apply at tasseling. If we get much later, especially those later applications into milk, we don't always see the benefit of the standability. But I will say this, it is very hybrid dependent. It's very environment dependent. If we have other stressors, such as, drought conditions or things like that, that's going to influence the standability. So it's hard to pinpoint that the effect on standability comes just from a fungicide, right? Because there's so many other factors at play, including hybrid and the environment. But where we have seen the most consistent response with standability and fungicide is when we apply it at tassel.
Okay. And then there's a question that came in, and it relates a little bit to what you and I talked about before we started the webinar here, and that is the current method in terms of looking at corn hybrids that are shorter in stature, shorter in height. And one of the questions that came in is for wind damage prevention, somewhat related to this, have you seen healthier stalks compared to non-treated? So you could probably relate this to conventional corn and then maybe segue into some of your observations and some of the shorter stature corn and where fungicide applications may be placed. I think you've done some research and observations as well.
Yeah, I mean, I can tell you that again, it's very hybrid dependent on standability. And so I think a fungicide, if a hybrid doesn't have good stalk strength, I'm not sure a fungicide can make up for that, right? Fungicides control diseases, foliar diseases. You know, we haven't seen good efficacy at them controlling stalk diseases because those are later season, usually later season type events. But what I can say is that, you know, if we're applying a fungicide and you're keeping that corn healthy, I think that's good. But I don't think that we can ask those fungicides to also keep our corn standing in a very high windstorm. I think that's maybe too much to ask and rely on them to do that. For short stature corn, you know, we've worked on that for, I think we've tested it now for a couple years. Looking at fungicide aspects of it, looking at disease control, comparing some application methods. And I mean, I think it's got great promise. They have very good hybrids. You know, they are easy to get across with a ground rig in our studies and very easy to spray. So I think there's some potential there, particularly if we're thinking about standability in strong storms. I do think that's a great way to try to counteract some of the problems of the really tall hybrids.
Another question in here is a little bit more about on thinking about mode of action here. Okay, going back to some of the fungicide basics. One of the attendees asked a question: does strobilurin fungicides result in more green tissue at harvest? If that's a concern, you know, would switching to a triazole or SDHI be better for late season application? And I think we're talking about, the harvestability and things staying green longer than needed or anticipated. Any comments there? Now, that could vary by latitude to some extent as well.
Yeah, I can tell you from my work at Purdue and Kentucky, what we find is it really doesn't break out by fungicide class. Any fungicide that we're applying later in the season is going to keep your corn at least 1 to 2 points wetter. So we see this very consistently, whether we're using a triazole or a QOI, is that if we're applying it sort of in that milk to later stage, our corn is wetter when we try to harvest it. And so that can be an impact when we think about economics. If we have to dry corn, or if you have a lot of corn to get out and it's wet and you have to leave it there to dry, it can impact your crop. So using a different fungicide, I'm not sure that you would see enough differences to just use a different fungicide class. We see it pretty consistently.
Talking a little bit about latitude, one of the questions that came in, and this might be, and I think you're a good person to talk about this because you've had experience in the South, the Central, and the North here. But have you looked at how these corn fungicide responses in general change with latitude? In other words, has the yield response diminished as you move north in the United States?
So is the yield response diminished as you move north? So I'm thinking through our data sets, and we have not seen that play out in our data sets. We did do an analysis by planting date, which would sort of include that latitude change, right? Because there would be differences in planting date, and did not see yield responses are going to be mostly tied to disease pressure. And so whatever disease pressure you have, whatever latitude you are, that's going to be the driving factor for what type of yield response you might see.
Okay. Uh, at this point, I don't have any other questions that came in. I think we talked a little bit about this balancing act, and I maybe one from my coworker here. When we think about these plant health applications, or what people are going to either experiment or put into their program and so forth. But the other concern we have in other crops in Minnesota, such as in sugar beets and so forth, is resistance management. Okay. Are there other unintended impacts of some of these prophylactic applications that we need to at least think about in terms of that situation? Maybe we haven't gotten there yet, but there's always a potential. Any comment on that?
Yes, that's a really great point to bring up. If any of you are in soybeans, we now have in most states at least one of our fungi that's important is resistant to multiple fungicide classes. And when you get more down into the south here, we have multiple fungi that are resistant to multiple fungicide classes. So this is a really big problem, and we're now starting to test it in corn. My lab, we worked with Marty Chilver's lab at Michigan State. We did a lot of testing on the fungus that causes northern corn leaf blight, and we're finding some sort of, I would say, not alarming, but it wasn't as sensitive as we would have liked it to be. And so there's some things that are starting to shift and change because you have to remember anytime we use any fungicide, doesn't matter what class, it could be a QOI, it could be a triazole. Anytime we're using these fungicides, we are selecting for what is already resistant in the population. And so over time, you're just going to be building up and helping it sort of shift and evolve over time. So it's always important to be thinking about, do we need to be applying these fungicides? Because if we're careful about how we do that, these fungicides can be around for us to use for disease control for a long time.
Okay. I know we didn't really spend a lot of time talking about soybeans, but I know you wanted to call him out if he was on here. But we have Dr. Melvick, and I don't know, Dean, if you want to close this session out. Any comments of what we've talked about and so forth with Kirsten, if you have your microphone on?
Yes, hello everybody. I'm here. I've been answering some questions on text and chat. So thanks, Kirsten. That was really good. Um, I'm not sure if anybody has any other questions that I might answer. I've answered a few, like I said. So one of the questions that came up, and I'll just say, some of you noticed that Minnesota wasn't included in that last set of uniform fungicide trials. We've done some of our own fungicide trials here in Minnesota and have summarized some of that information on Minnesota Crop News. Some of that work was led by Bruce Potter, and we've done some other things too. So we've done some separate things that weren't part of this. So that's one point. We don't see a lot of foliar disease across a lot of Minnesota, unlike we see or they see in Illinois and Southern Iowa and Kentucky, right? It's a little different here. Southeastern Minnesota certainly has changed since tar spot came in the picture, with the exception of last year. But our results are a little different, and our sort of targets are a little different. Dave, you said something about soybeans. Is there anything that's come up that?
Yeah, well, I had one other just quick question for Kirsten before we jump over there, and that goes back to what we talked about in Xyway and so forth. But this is, coincidental into it. And it said the question is, are those in-furrow fungicides or fungicides in general detrimental to the soil microbiology, so to speak, or the microbiomes and so forth on that situation? I don't know. That's obviously not a facet of the multi-state, multi-year work, but that might be just a question if you've seen any indication one way or the other, Kirsten.
Yes, and that's a great question that we haven't fully addressed in our research. I don't know if anyone has, and Dean might be able to comment on this as well. But one of the studies that I always go back to when we look at this is a study that was done in turf where they were looking at sort of these drenches, soil drenches of fungicides on the greens, and then they looked at the microbial community. And what they were finding is that you initially get a dip in the population of beneficial soil organisms, but within a year, it's normal again. So it rebounds very quickly because there's just so many soil organisms out there. So I'm not sure if that translates into the field crop world. I know that some of our colleagues have some interest in studying that, but it is something that takes some time and a lot of research power to study. And so I think it might be a little bit before we find out the answer to that question.
Now, Dean, I know that next week you're going to be on the webinar and talking about corn and soybean updates. Is that correct? And have a chance to dive into this a little bit more in depth.
That's right. Yes.
And we're talking a little bit about that. And of course, Kirsten, last year was a drier year in the upper Midwest. It's hard to predict with La Nina and El Nino what's going to transpire. We've been dry through the winter time. We're expecting rain and snow here, but nonetheless, it's hard, to know those things. I don't know if there are any other comments, Kirsten. I know that in the Crop Protection Network, you want to mention again that in addition, obviously, to the corn trials, but the soybeans are quite exhaustive in terms of multi-year and multi-state as well, correct? In terms of their efficacy ratings?
Yes, our efficacy guides for soybeans are very comprehensive as well. A lot more products in soybeans, so it's really worth checking out. And we also have a soybean seed treatment
Right.
table as well. And my final comment would really be, you guys are really lucky in Minnesota. Dean is a great plant pathologist. He's got a lot of good data. So I gave you sort of the national overview, but he's a great resource for those specific recommendations.
Yeah. I think the last time, I'm going to just leave this with one question, and we've maybe dwelled on this quite a bit. I guess in the future, will in-furrow fungicides ever become profitable? Now that may be, a bridge too far to really talk about there, but there's some limitations, and I know in the herbicide world where I am, we talk about season long, efficacy, and it's not always there. Same thing here in terms of that, if we look at that type of a situation, or is there something on the horizon?
So I can give you my perspective from Kentucky for how the in-furrow fungicide Xyway really fits in here. And I know this is going to be different in Minnesota, so take it with a grain of salt. But in Kentucky, we have small fields, weird shaped fields. We have fields that we're not going to be able to get big ground rigs in. We're not going to be able to get any aerial, maybe drone, but maybe not. Those applications aren't going to go on. And so there are fields that might need a fungicide application like in a river bottom, but there's no way to get applicator equipment in there. And so Xyway is a good fit there. It will control things like gray leaf spot and northern corn leaf blight. It might not be profitable in the data sets that we showed, but if it was a year where we had a big GLS, a gray leaf spot outbreak, who knows? It might be profitable in that situation. And so I think that there's a fit for it in Kentucky in certain areas. And I think it's just something that each farmer has to sort of think about what options they have available for disease management and how they want to position it in their own system.
Well, thank you very much.
Just
Kirsten,
like to
Dean,
comment.
last words?
I think Dean had
Minnesota.
something.
Yeah. That was really nice, Kirsten. We don't have as much data, from university trials up here, partly because we don't have the same kind of diseases you're seeing at the same levels. But I've seen some very promising results for some of these soil-applied fungicides, like you're relaying, and from not only Kentucky, but from other states as well. And I've heard some promising results in Minnesota. I think overall, based on that big, broad question that we just asked, I think the jury's still out. I think we have a lot to learn about those and how well they might work. And I'm sure there'll be new active ingredients coming out that'll be used in that application mode as well. So I guess stay tuned and we'll watch those and see how they develop, and the application technologies are changing too.
All right. Well, thank you, both of you, for becoming part of our strategic farming today in terms of that. So we thank you, Dean, but also really thank Kirsten for coming into us from the University of Kentucky. So at this point in time, I want to thank folks for attending the Strategic Farming Let's Talk Crops program today. We want to especially thank the Minnesota Soybean Research and Promotion Council, along with the Minnesota Corn and Research and Promotion Council, for the generous funding for this.